Video, we're going to focus on solid-state propulsion method called ionic drive. One of the most fascinating methods of flying is by an aircraft that uses electrohydrodynamics to create thrust and lift. There are two key advantages to this method. First is that they do not require any moving parts, and the second is they are silent. A buzzing sound may be heard, but in most cases it's not audible. Interestingly, the concept has been around for 100 years. Most recently, we saw a drone video by a startup called Undefined Technology that claims for a 4.5-minute VTOL flight. But is this technology really feasible? Let's find out. There are different methods of creating propulsion using electrohydrodynamics that have been explored. One is called ionic wind, the second method is called an ionic thruster, and third is a plasma jet. The commonality in all methods is the creation of charged particles and their acceleration afterwards through a magnetic field. In recent times, there has been some activity in the ionic wind propulsion method. The mechanism is fairly straightforward. You have two electrodes at extremely high voltages, that is in the tens of thousands. The positively charged electrode upstream ionizes the air and more specifically nitrogen molecules. These positively charged nitrogen particles are then attracted towards the rear to the negatively charged electrode because of the magnetic field. While traveling, they also knock other neutral molecules in their path and therefore create a draft which we call ionic wind. The ionic wind phenomenon has been known since the 1920s, and we saw increased activity in the 1960s. In a famous televised demonstration in 1964, Alexander D. Seversky flew what he called the ionocraft. He demonstrated the hovering of a machine with no moving parts of 57 grams mass and with just 90 watts of power. The ionocraft was consuming 3 milliamps current at 30,000 volts. This translated to 0.63 kilograms per kilowatt or 6.2 newtons of lift force per kilowatt. The problem was that the power for it came from a cable to which the ionocraft was tethered. Another point to be noted here is that the design consists of several needles that stick out. This method of ionizing nitrogen is the more efficient method. As the 1960s were very optimistic times, it was envisaged that in the future, energy would be beamed up to the ionocraft in the form of microwaves or lasers. If not, then panels on the ionocraft would convert solar energy into electricity to stay aloft. Needless to say, that did not happen. But as the battery technology and power electronics improved, there was a renewed interest in the electrohydrodynamic aircraft and in particular drones. These silent drones could deliver packages in urban environments or carry out reconnaissance. The bane of this technology remained the low thrust and high energy consumption. Now, without onboard power system, the thrust to weight ratio was more than 1 and the ionocraft could take off vertically. But with power coming from an onboard battery, the thrust to weight ratio does drop. Despite that, Ethan Krauss of Electronair was able to develop a VTOL aircraft in 2006 that did achieve VTOL with onboard power. Engineers do realize that we don't need a thrust-to-weight ratio of more than 1 to fly. We only need that for VTOL. Bearing this in mind, the MIT team set out to make a fixed-wing aircraft that could be launched from a sling. In 2018, they were able to show a sustained flight in an indoor space. It was a sight to behold as the aircraft flew without any propeller or any turbine engine. The aircraft in question was the MIT EAD V2 and had a wingspan of 5 meters and weighed just 2.5 kilograms. It had thin electrodes that extended through its wings. Using its 500-watt lithium polymer battery, the thin wires at the front are charged to a positive 20,000 volts and the aerodynamic electrode behind was charged to a negative 20,000 volts, creating a strong electric field and thus producing ionic wind. In the 10 test flights, the plane successfully flew about 60 meters in about 12 seconds with a thrust efficiency of about 2.6. It has been estimated that with faster speeds, the efficiency of the system will increase. Theoretically, at about 1,080 kilometers per hour, which is faster than a passenger plane, it will reach 50% efficiency. These flight tests got NASA interested, and it awarded researchers at the MIT a grant to further develop the EAD, or the Electroaerodynamic Propulsion system. Professor Stephen Barrett, who oversaw the development of the MIT solid-state aircraft, is now working on novel, multi-stage ducted electroaerodynamic thrusters, in which multiple thruster stages are enclosed inside a duct. It will be used to increase the thrust enough to enable VTOL operations. Interestingly, there are curious individuals who have developed a multi-stage electroaerodynamic thruster at home, as they are quite simple to design. One effort that is worthy of mentioning is by Jay Bowles of Plasma Channel. In his DIY multi-stage thruster, he was able to get a flow speed of 2.3 meters per second at 90 watts of power and got 22 grams of thrust. However, this wasn't the most efficient design, as 1 gram of thrust per watt has already been achieved. The ionization efficiency needs to be improved. To do this, the electrode wire thickness has to be optimized. Furthermore, finding the optimal breakdown voltage, varying the voltage as the speed of ionic wind changes, and finding the right distance between the multi-stage propulsors is also required. But apart from this, are we missing a trick that will make the propulsor even more efficient? If we know, then we will realize that there has rarely been a marriage of electrical system with the fluid dynamic system while designing an EAD. It is mainly the fluid dynamics portion that is being ignored. By having a nozzle at the end of the ionic thruster, the velocity of the outcoming air can be increased, which increases the thrust. Also, by enabling the air to be collected from the surroundings, or in other words, by fluid entrainment, the thrust can be further increased. So, what do you guys think about this technology? Do you think it has the potential? Do let us know in the comment section. And with this, the video is concluded. Thank you for your attention.